Good day, STEM students. Now that we're done with discussing physical quantities as well as units, we will proceed with another lesson, which is measurement. Let's start this lesson by defining what measurement is. Measurement is the action of measuring something. It is the size, length, or amount of something as established by measuring. It is subject to either systematic or random error. Measurement can be accurate and precise or the opposite. For us to be able to understand better each of these definitions, we will expand them in the next slides. The first thing that we should know about measurement is the action of measuring something. And we will not be able to conduct measurement if we don't have the so-called measuring devices or equipment. Here, I will present to you some of the commonly used measuring devices, especially in our study of physics. The first one, we have thermometer used for temperature. We will also need multimeter, which is used for measuring voltage, current, and resistance. We also have the timer, and it is used to measure time. And then we have the graduated cylinder, which is used to measure volume. Aside from this, we also have several measuring devices used for measuring length. And we know that in physics, length and distance are very important. Here are the examples of measuring devices. We have the measuring tape, the ruler, and the meter stick. Usually, the longest among them will be the measuring tape, which goes from 1 meter to can even measure a kilometer, if I'm not mistaken. And then the next one, if you want a shorter measuring device, we can use meter stick, and then we can also use ruler for measurements that we do on paper. Another measuring device, which I am not sure if you are familiar with, is what we call the vernier caliper. The vernier caliper has three major parts. What are those parts? The internal jaw, the external jaw, and the depth measuring blade. Okay? Let's discuss first the role of the internal jaw. The internal jaw is used to measure inner diameter. So for example, you become an engineer, chemical engineer, sanitary engineer, or whatever engineer, you need to know the internal diameter of pipes that you're going to use in building different houses or different in the case of chemical engineers, usually they deal with water stations, water reservoir and stuff. So they need to know the inner diameter. Okay? Next, it can be also used to measure the materials for containers, just like this one. The cover of a plastic container. It's also important so that you would know if it would fit the container that you have manufactured. Next important part of the vernier caliper is what we call the external jaws. The external jaws, if the internal jaws are used for measuring inner diameter, the external jaws are used for getting the outer diameter. So you can use it for this kind of things, circular things, spherical things. to get the outer diameter. And then we can also use it for simple things like this keychain here. So it can either be the manual, not manual, the analog rather, and digital. Of course, it's more convenient to use the digital nowadays. So this one is the analog one, wherein there are rules that you should know to be able to measure the outer diameter of this one. On the other hand, the digital one will already show you the measurement in this LED screen. Next, important major part of our vernier caliper is the depth measuring blade. The depth measuring blade is used, of course, to measure the depth for small objects. So for example, the dents of um, materials you will use in construction, no? So usually these are very useful if you become engineers someday. It can also be used by plant biologists because this can be used to measure the depth of the soil where you plant several seeds, because if you don't know yet, there are several seeds which requires specific depth of burying for maximum results or better results or faster growth for plants. Okay, the next thing that we should know about measurement is that measurement is subject to systematic and random errors. Let's first define what systematic error is. Systematic error is the one that deviates, sorry, nakapag-Tagalog ako, no? See, when we say systematic error, those are the ones that deviates from the true value. When we say deviate, it means that there are times that you would be able to measure things that differs from the true value. So deviate here means differ, okay? Or have a difference from what we call the true value. So that's one of the keywords that you should remember, the true value. Again, systematic error is the one that deviates from the true value of the measurement by a fixed amount. Okay? Next, systematic error remains constant or changes in a regular fashion in repeated measurements of the same quantity. So you will be able to identify a systematic error if the error is repeating as you repeat the measurements. Usually kasi if you are able to measure something and there you are comparing it with a true value, your goal is to keep measuring until you get a value that is very, very close to the true value. But most of the time, since measurement nga are subject to systematic errors, there will be a difference. And then, if the difference is actually constant or regular, it is considered as systematic. Di ba nga, when we say systematic, it means organized, okay? Constant. And if it changes, the change is regular. That's systematic, okay? Now, what are the sources of systematic error? Here, observational error and imperfect calibration. When we say observational error, this one deals with human error, meaning it could be a person measuring it and his or her eyesight is not properly working during that time. So instead of a certain specific reading, he was able to see a different reading or measure a different reading, no? Or it can be imperfect instrument calibration, meaning there is something wrong with the way you calibrate your measuring device. Usually measuring device are calibrated by experts so that they would be able to measure the real thing, that just like in the market, the weighing scales in the market are supposed to be accredited, investigated by certain experts so that the people in the marketplace, the sellers, will not be able to fraud the buyers. And if the buyers, if the sellers are able to do something in the instrument, it will not be able to measure a value that is the same as the true value you are trying to measure. Here are specific examples of systematic error sources. Not reading the meniscus at eye level for a volume measurement will always result in an inaccurate reading. The value will be consistently low or high depending on whether the readings is taken from above or below the mark. So what does the word meniscus mean? It means the U-shaped, the upper surface, a liquid in a tube. So how do you read it? You should read the lower meniscus. This usually happens in liquids, especially in graduated cylinders. So you don't read this one. It will form a U shape, right? This is the U shape. So you can see that's approximately U. Instead of reading the upper, you need to read the lower meniscus, the one that is near the bent part of your U. Okay, let's have another clearer example. So what do you think is the reading here? This one is the meniscus. Okay, that's the U-shaped. Would you read this one, or this one? Is it A or B? If you choose A, that's 15, this one's 15, 16, 17, 18. B is 18 and then A is 19. Okay, the answer is the 18 one. This one, letter B. Because again, you should read the lower meniscus. If you read upper meniscus, that's because you are under the source that is improper, improper human error, okay? Next, measuring length with a metal ruler will give a different result at a cold temperature than at a hot temperature due to thermal expansion of the material. This one is under the source of systematic error, that is improper calibration. You don't know how the measuring device works. So you should consider the factor of temperature in calibrating your measuring devices. Usually the rule is this: metals expand when it is hot, or if the temperature is hot, and then when the temperature is cold, metals shrink. And what does that mean? It means that during hot summer days, the ruler will measure longer distance or longer length compared with a measurement done during cold weathers. Why? Because during summer days, this one expands, meaning it becomes longer. During cold days, metal shrinks, which means that the metal becomes shorter. So during hot summer days, your measurements are longer. During cold weather, your measurements are usually, yes, shorter. Okay? So how do we minimize systematic error? Number one, to improve the structure of the apparatus. So if you can do something about the apparatus, do it. And properly calibrate the apparatus. Okay? Okay, now let's proceed with random error. When we say random error, these are the one that varies and which likely to be positive or negative, meaning it can be an increase in the measurement. For example, you measure the length and at first you measured and then it is uh, it increased from the first measurement, and then on your third measurement it decreases at a different number, and then you measure it again. You keep repeating measurements, but sometimes it increases and sometimes it decreases. It is random, came from the word itself, random error. There is no pattern. It is inconsistent and does not repeat in the same magnitude or direction except by chance. So yun nga, as I said a while ago, no, it can be an increase in the length or a decrease in the length. It can be at first it's 1 centimeter increase in the length, and then in the second measurement it's 2 centimeter decrease in the length. Random siya. There is no consistent number unless by chance, very, very, very small chance. So what are the sources of random error? First is incorrectly using the apparatus. For example, measuring the temperature of water in a container. How can you be able to commit an incorrect measurement using this apparatus? Now, if you measure the temperature of water in this container, there are times that some experimenters just leave the thermometer in the container. In that case, the tip of the thermometer touches the bottom of the container. So in that case, instead of being able to measure the temperature of the water only, you are actually measuring the temperature of the bottom of the container. So it defeats the purpose. You were not able to use the apparatus correctly by measuring the one that you're supposed to measure. Instead of measuring the water temperature, you measure the container's temperature. Next, environmental or surroundings. Those are the other source of random error. Example, you did not expect the temperature change. In the morning, uh, you get different results, and in the afternoon you get different results, and usually that's because the temperature is actually changing. So if you conduct experiment, especially when you are already doing your research, the time should be consistent. So for example, you measure the temperature, no, you measure a certain physical quantity, let's say the humidity. Okay, you want to investigate humidity. Of course, the humidity in the morning will not be the same as the humidity in the afternoon. So if you want to really see if your experiment is working properly, you should do the measuring all at the same time during the duration of your experiment. So let's say that your experiment is 1 week. At Monday, during Mondays, or on Monday, you should measure at 8 a.m. The same time, you should be able to measure on Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. There should be no changes in the time unless time is a factor. So you're going to have a set of data for the morning and a set of data for the afternoon, okay? But still, your data are grouped as the morning data and the afternoon data. And another environmental interference could be caused by sudden gust of wind. Okay, it can interfere with your measuring How do we minimize random error? Just increase the number of trials. Keep on trying and trying. The more the trials you do, the lesser the random error. Okay, thank you for listening for our lecture about measurement. That's just the part 1, and we will have the part 2, which will be about accuracy and precision.